an example now. So this is worked example 13 using Demoivre's theorem. So I'm going to write down, as soon as I see that I've got powers here in the examples, I straight up write down Demoivre's theorem. And it's just so that you get this in your head. So Demoivre's theorem, which states that we've got r cis theta to the power of n is r to the n cis n theta. So looking at the first example here, A, we've got cis pi on 3 all to the power of 9. So the other thing to be aware of here is sometimes if there's nothing in front of the cis, the assumption is that there's a 1 there. Okay, so this is actually 1 cis pi on 3. The assumption is that the modulus is 1. So expanding this out, we take the modulus and do that to the power of 9, which is nice because anything, 1 to the power of anything is still 1. And then we take the angle and we multiply that by the power, which is 9. So our answer is going to be 1 cis, and then we're going to have 9 pi on 3. Now 9 pi on 3 is 3 pi. So if we think about where 3 pi actually sits, pi, 2 pi, 3 pi is actually here. So 3 pi is the same as pi. So what our answer is here is actually that we're going to have cis of pi on 3 to the power of 9 equals 1 cis pi. And what we should do is really give that in Cartesian form. Okay, with Demoivre's theorem, usually give your answers in Cartesian form. So I'm just going to go over to the next side. So we had 1 cis pi. That's equal to 1 outside of, remember that cis is cos plus I sine of the angle, which is pi. And we know that cos of pi is -1 and sine of pi is 0. So there's no imaginary component. So we just end up with the purely real number, which is -1. So therefore, for this particular one, even though you started off with a complex number, which was cis pi on 3, when you raise it to the power of 9, you end up with a purely real number. Okay, we'll do B as well. So you can try B without me. See how you go. So we've got 7 pi on 4, cis of that, over cis of pi on 3, the power of 7. The power here is on the bottom. So what I'm actually going to do is I'm just going to work with that bottom line, okay, and figure out what that is using Demoivre's theorem. So 1 cis pi on 3, just putting the 1 out the front. So using, and I'm just going to put Demoivre's theorem like dm. I'm going to now have that that's equal to 1 to the power of 7 cis 7 times pi on 3, which equals 1 cis 7 pi on 3. And you want to think about where 7 pi on 3 is. We know that 6 pi on 3 would be all the way here to 2 pi. So 7 pi on 3 is actually the same as pi on 3. Okay, like that. So now what we want to do is actually work on the whole division now. So cis of 7 pi on 4 on cis of pi on 3 all to the power of 7 equals cis of 7 pi on 4 over cis of pi on 3, which equals, now using Demoivre's theorem again, we know that this is going to be the numbers out the front. Now if there's nothing out the front, you can put a 1 there. It's 1 over 1. Cis the top angle minus the bottom angle. Okay, like that. So we've got 7 pi on 4 minus pi on 3. We know it's 1 over 12. 7 3s are 21 on 12 minus 4 on 12. Okay, which is, what's that, 17 pi on 12. Okay, and if you're thinking about where that actually sits, this is going to be a non-standard angle, so we're not going to go to Cartesian form here because it's over 12. 17 pi on 12, this would be 12 pi on 12 here. And remember that we can, I'm going to put this in arg form, so big ARG. We can only go to 12 pi on 12 on, shouldn't say 12 pi on, pi should be 12 pi on 12, which is pi. So we're going to go back this way for 17 pi on 12. This would be here, 2 pi, would be 24 pi on 12. So we know that we're 5 off that. Okay, so I should say 7 off that, not 5 off that. So we know that our answer is going to be this way negative, because we have to come around to the angle here. Okay, and to get back to 17 pi on 12 from 24, we have to go back 7. So our answer is going to be negative 7 pi over 12. So for this example here, our answer, cis of 7 pi on 4 over cis of pi on 3 to the power of 7, leaving it in cis form because it's a non-standard angle, is the cis, 1 cis, negative 7 pi over 12. So both of those examples, because they've got powers in them, we're using de Moivre's theorem.